Let's go to page 382. This is lesson 8-7, and the objective of this lesson is to find rational roots of polynomial equations with integral coefficients. Okay, so over here you have 6x to the 3 plus 8x squared minus 7x minus 3 equal to 0. So to solve this equation, notice before they kind of give you one of the answer, like one of the root, and then from there you can go and lower your equation by dividing, right? But now they don't give you anything at all, so you have to start from scratch. You have to find out. You need to go and figure out what are all the answers are without any additional clue. Okay? So first you need to do is you have to do a try and error. But when you do try and error, there's infinite number of possibilities, right? So you need to narrow down the possibility that you want to try. Okay? And so the way to do it is you need to compile a list of possibilities, okay, for rational roots. So what you need to do is first you need to find all the factors of this number. So the factor of the 6 would be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. So these are factors of these. So find the factors of the first number, then find the factor of the last number. So it would be plus, minus 1, plus or minus 3. The next thing you have to do is you have to use this divided by this. Okay? So you have to use this list divided by this list. So 1 over 1 will give you plus or minus 1. 1 over 2 will give you plus or minus 1 over 2, right? This over this. And this over that will give you plus or minus 1 over 3. This over this will give you plus or minus 1 over 6. So you're done with the 1, now you have to do the 3. So 3 over 1 would be plus or minus 3. 3 over 2 will give you plus or minus 3 over 2. 3 over 3 is 1, which you already have, so you don't have to do it again. 3 over 6 is 1 over 2, which you already have. Okay? So these are the lists that you want to try when you're doing the try and error. Okay? So don't try any number that is not on the list, because it's not going to work. Okay? So this is a list of the number that you can try, that you want to try. And then after that, you have to use a synthetic division to try. Right? So since we're over here, let's go and try these things out. So what you need to do is you need to compile a list, okay, of the number that you try. Okay, and you want to use a synthetic division. Okay, so you're going to get 6, 8, negative 7, and negative 3. Okay. Now, the first number you always try is 0. Now remember, synthetic division and evaluations are the interchangeable, right? So x, and this is p of x. P means polynomial. So you always try 0. Okay? But instead of putting the 0 over here to do it, it's easier if you just use evaluation. So put 0 in here, in here, in here. So all this is going to be gone, right? Because put 0 in here, all this will be just 0. So p of 0 will give you negative 3. Okay? So this number always go over here. And the reason you want to keep track, so because you're doing try and error, you want to know if you're going the right direction or wrong direction. So this will give you a clue. Okay? Just playing the game of, when you're looking for something that, looking for a hidden object, and the person will tell you, okay, you're getting hot, or cold, right? So that's how. So think of like that kind of game. Okay, the next number I want to try is 1, because 1 is the easiest number to try. So by having 0 and 1, I can see what direction I need to go. Okay, and so I use a pen to make this part. Then I'm going to use pencil. Okay, and the reason I use pencil so that I can erase, and I don't want to take up so much room. Okay, so I'm going to try 1. Right, 1 is on the list, right? 1 is always on the list. So I'm going to try 1. Okay, so I'm going to drop. Use your fingers, so multiply. And you put over here, you add. Okay, multiply. You add. Multiply. Right, you add. Okay, so when I try 1, I get 4. My goal is try to get to the 0. Okay, because if it's 0, then that means that's one of the answer. Okay, so if you notice from here, I need to get to a 0. So when I try 0, I get negative 3. When I try 1, I get 4. So notice that 0 is somewhere in between. Okay? So that means the number I need to try should be somewhere in between. Okay, so what number is between 0 and 1? Well, between 0 and 1, there are 3 numbers. So you want to try one of those 3 numbers. Okay? And so I'm going to try, okay, so let's go and try 1/2 and see what we get. Okay? Again, see the reason I use a switch to pencil so I can erase, right? And I use a pen for that. See that? Okay? So I'm going to try 1/2 and see what I get. Okay? So let's try 1/2. So put 1/2 over here. So you drop, multiply. Okay, so drop, multiply, you add. Now I can see it's not going to work because it doesn't come out nice. So when you multiply, you get 11/2. And when you add, you can use your calculator. Okay, so 14 should be -3/2. When I multiply, I get -3/4. When I add 12, so -15/4. Okay, so when I try 1/2, I get -15/4. So it's still below 0, so I need to get higher, okay? Because I need to get a 0, so I need to go up there a bit higher. It's getting close, okay? Because I guess I start from -3, I get -15/4. So I'm going to try a higher number, get closer to 1, okay? Because 1/2 is still not enough. So I'm going to try one. So I'm going to try. Let's see. But again, this is not a guarantee though. Okay, so this is not a guarantee. So I'm going to try maybe again. So I want to try some positive numbers over here. So let's go and try. Okay, let's go and try 3/2. But again, this kind of give you some clue. But again, this is not a guarantee. Actually, okay, and okay. So over here again, you keep trying, and again, notice it's supposed to be between here, and notice it's not going to work. Okay, so what you have is you're going to have some kind of complex number that is not going to work. Okay, because you suppose so. If you look at the clue over here, okay, it's supposed to be somewhere in between, but notice the number getting worse than that. Okay, so it tells you that there's a complex numbers, so it's not going to work. So what you want to do, you want to try the other direction, see if you can get some numbers. Okay, and so you can just try any number, and keep track so that way you can see what you tried, already. Okay, but anyway, so try a whole bunch of numbers, and so again try, and eventually you're going to get to a number that is -1/3. Okay, again try all different numbers. So when you get to have -1/3, okay, so you drop, you multiply, you add, okay, multiply, you add, multiply, and you add. So when you try -1/3, you get 0, okay? So that means this is one of your answer. So -1/3 is your answer. Now once you get that, okay, you kind of stop, don't do anymore, because once you get to quadratic, you don't want to keep doing this. Do try and error, it takes too long. So from here, you can go and get your depressed equation. You got 6x squared plus 6x minus 9 equal to 0. Okay? Then from here, you can divide it by 3 to lower your number. So you got 2x squared plus 2x minus 3 equal to 0. And then from here, you can go and use quadratic formula. So a equal to 2, b equal to 2, c equal to -3. Okay, so you got x equal to -b plus or minus square root of b squared minus 4ac over 2a. Okay, and so you can work it through. So you got -2 plus or minus square root of 4 plus 24 over 4. And then I can continue to work. So you're going to have x equal to -2 plus or minus square root of 28 over 4. So x equal to negative 2 plus or minus, you can simplify that, become 2 square root of 7 over 4. And divide everything by 2. So reduce everything by 2, so you're going to get negative 1 plus or minus square root of 7 over 2. Okay? So your 3 answers, again, this is a cube equation, so you're going to get 3 answers. So your 3 answers are negative 1 over 3, negative 1 plus or minus square root of 7 over 2. Okay? So the problem gets pretty complicated, so make sure you understand the technique and have patience to go through. Okay? Okay, so let's go to example 1. Okay, so you got 2x to the 4 plus 3x to the 3 minus 7x squared plus 3x minus 9 equal to 0. Okay, so again, let's compile a list of factors. So factor of 2 would be plus or minus 1, plus or minus 2. The factor of 9 would be plus or minus 1, plus or minus 3, plus or minus 9. Then you have to use this over this. Okay, so this over this would be plus or minus 1. This over this would be plus or minus 1 over 2. This one would be plus or minus 3. This would be plus or minus 3 over 2. This one would be plus or minus 9. This would be plus or minus 9 over 2. Okay, so this is the list that you need to try. Okay? Okay, so that's one, keep track of what we have. So this would be x and p of x. Okay? So again, you all start with 0. Okay? When you put 0 in here, all this would become 0, right? You put 0 in the x, all this become gone, so this would be negative 9. Okay, so this is your starting point. And again, next number I'm going to try is 1. Okay, so that way I can see which direction I need to go. Okay, so I got 2, 3, negative 7, 3, negative 9. Okay, and I'm going to try again. I'm going to switch over to the pencil. That way I don't want to I can erase and and once I write it down here, I can erase and start it over. Okay, I'm going to try 1. So you can drop. Okay, multiply, add, multiply, add, multiply, add, multiply, add. So when I try 1, I get negative 8. Okay, so notice I'm getting closer, right? Again, I want to get to the 0. So I'm getting closer. So I'm going the correct direction. So what I'm going to do is I'm going to try 2 next. Okay, I'm going to try 2. Again, the reason I don't want to do the fraction right away because fraction is harder to do. So I'm going to do the integer first and to get an additional clue. Okay, so I'm going to try 2 next and see what I get. Okay, so drop, multiply, add, multiply, add, multiply, right? Again, you multiply, add, multiply, and add. So when I try 2, I get 25, so way over, okay? So that means the 0 is somewhere in between here, right? 0 is between here. That means the number should be between here. And so you go to the list, okay, what number is between 1 and 2? Well, this one here, right? 1.5, 3 over 2 is 1.5. So that's the one I'm going to try next. Okay, so again, that's why you want to keep track of what you did and use this as a clue. Okay, again, you want to get to the 0, so you kind of have to play the game of hot cold, right? Okay. Okay, so over here we're getting cold. Okay, so we need to go back a little bit. We went over too far. So go 3 over 2. So you drop, multiply, the 2 and 2 cancel out, so you get 3, right? Okay. Okay. Let's go to the next one. So you add, so again multiply, and you put over there, you add, then you multiply, so 2 and 6 cancel, get 3. 3 times 3 is 9. Okay, you add, 2 and 2 cancel out, so multiply, get 3. So you add, right? Again, multiply, put over here, you add. Okay, and this is the same as over here, so you get 9. So you add, you get 0. See, there you go. So this is one of the answer. Okay. Now, once you get the answer, don't go back to the list again. You want to notice, and another thing you want to compile a new list, repeat the process. But notice you got 2, 6, 2, 6, right? When you have pattern repeated, when you have the same ratio like that, that means this is factorable. So what you want to do is you want to go and put this as an equation and do the factoring. Okay. So you're going to get 2x to the 3 plus 6x squared plus 2x plus 6 equal to 0. Right? Again, this is going to be the remainder. So the 0 power, 1, 2, 3 power. Right? Okay, so again, I'm going to group them, do the factoring using grouping. Okay. And then go and factor out the x squared. Okay, factor out the x squared. Then I'm going to factor out the 2x plus 6. Well, actually, what I need to do, I should divide them by 2. Yeah. Okay. I should divide them by 2, but doesn't matter. Okay. In the future, what you want to do is dividing by 2, so you get x cubed plus 3x squared plus x plus 3 equal to 0. Okay. So that's going to do that. Okay. Okay. So dividing by 2 to lower my number, so easier to work. Then go and do the grouping. Okay, and then factor out the x squared from the top, from the first group, and go and factor it out. So you got x plus 3 and x squared plus 1 equal to 0, and set it equal to 0. So you got x plus 3 equal to 0, x squared plus 1 equal to 0. So from here, minus 3 on both sides. So you got x equal to negative 3. Over here, minus 1 on both sides. So you got x squared equal to negative 1. And then you can go ahead and take the square root on both sides. And so x equal to plus or minus I. Okay, so those are your answers. So you got 1, 2, 3, 4. So your answers are 3 over 2, negative 3, plus or minus I. Okay? Okay, let's go to example 4. Example 2. Okay, you want to show that the cube root of 9 is rational. Okay, so first, let's go and work backward to get our equation. Okay, so you have x, so your root x equal to cube root of 9. Okay, so that's what it's equal to. Then what you want to do is you want to go and cube both sides. So you got x cubed equal to cube and cube root cancel out. Okay, and then you minus 9 on both sides. So you got x cubed minus 9 equal to 0. So that's where this equation came from. Okay, and you want to show that this number is irrational. That means all the rational roots. So see, all these are rational roots. It's not going to work. Okay, and again, so you compile your list. So it'd be plus or minus 1. This would be compile. This will give you plus or minus 1, plus or minus 3, plus or minus 9. Okay, so this is the number that you need to try. Okay, right? Because this over this will be same. Now again, remember, synthetic division and evaluation are interchangeable, right? So these are all the possible rational roots. So you can substitute this into here, and so if you put 1 over here, you got 1 cubed minus 9 equal to 0. So this does not work. If you put 3 in here, 3 cubed is 27 minus 9 equal to 0, so it doesn't work. If you put 9 in here, you're going to get a huge number. So none of this work. So that means this would be no rational roots. Okay? So none of this work. So this equation has no rational roots. Or no rational root. Okay? Now, since this one does not have a rational root, that means, so therefore this is irrational. Okay? because again, no rational root will work. Therefore, this is irrational. Okay, so that's how you prove it.